Hi, so for today we're going to talk about still calculator techniques for engineering board exam. And for today's video, we're going to talk about how are we going to use a calculator technique in evaluating the derivative of a certain function. So derivatives. Okay, so how do we apply the calculator techniques in solving a derivative of the function? Okay, so but before that, we must make sure that our calculator is in derivation mode. So we have the shift mode. So 4. So we have a region mode. So please convert your calculator into region mode in case that there will be transcendental function involved in the calculation of the derivative. Okay, so let's get started. So for number 1, we have to differentiate this function. So we have y equals square root of 3 minus 2x squared. So the very first thing that we're going to do is we are going to differentiate this in our calculator. There is a calculator or a function of the calculator that can differentiate this with a given value of x. But we know that this is not, we have no given values for x. So we will be inputting a small value of x. So in this one, so we have shift and click this button, d all over dx, that's the derivative. So we input this. So we have square root of 3 minus 2 alpha x squared. And the calculator is actually asking what particular value of x. Okay? So actually the value could be 0.1, 0.3, or 0.5. Okay? So we know that the derivative is a small change. Okay? So what are we going to do? We will be going to assign is either you can choose from 0.1. If 0.1 does not work, okay, do not work, you can choose 0.3 or 0.5. So in this case, let's try 0.1. So we will be inputting a value of x 0.1. It means that the calculator will get the derivative of this function and substitute 0.1 on the x, and it will give us a value. Okay? So let's try. Let's click equal sign. So this is the value that we get upon differentiating this with the value of x equals 0.1. So we can shift this in our variable a in order for comparison later on. So upon doing this, okay, we are going to compare this answer to our choices. So what are we going to do with our choices? Simply, we're going to type this in our calculator, and we're going to input, okay, or we're going to calculate what value of x we have solved a while ago. Using the same value of x we have solved a while ago in the derivative. So, you know that this is 2x. This is our first choice. Okay? So, just press calculate. The calculator will ask what value of x should we substitute in this letter A. So, we will still use the same 0.1. And this is the answer. Okay? So we're going to compare this answer to the value of the stored constant on our calculation a while ago, which is stored in variable a. So if this equals to 1, if we divide this and this equals to 1, then that is the answer. So negative 1 is not the same as 1. So this is not the correct answer. Let's go now to number 2, letter B. 2 alpha x multiplied by 3 square root of 3 minus 2 alpha x squared. Calculate using 0.1. Okay, and that is the answer. Compare that or divide that with const or variable a. Okay, so that's not equal to 1. So definitely the letter B is not the answer. Let's try letter C. So we have negative 2 alpha x all over the square root of 3 minus 2 alpha x squared. So calculate using same value of 0.1, and this is the answer. So just click answer to compare it with the variable a, and then divide this by alpha a, and voila, we got the answer, which is 1, which is equal to the differential or derivative that we calculated a while ago. Take note, we use small numbers because we know that whenever we are differentiating, we know that there is a small change only, okay, when we substitute that value. So this equals to 1. So definitely letter C will be our answer. It's pretty easy, right? So number 2, what is the derivative with respect to x of quantity x plus 3, x plus 1 raised to 3 minus x cubed? So again, performing the same thing. Okay. So we are going to input that. Be careful with the parentheses. So alpha x plus 1. Okay. And this is raised to 3. And then minus alpha x cubed. Okay. Alpha x cubed. So we have to write again the parentheses, okay, because there is a parenthesis provided in the calculator. Okay, so let us use 0.1 or 0.3. Let's try 0.3. Okay, so 24 over 5, which is 4.8, we can shift it in our uh, variable a. Okay, 24 over 5, 4.8. So let's try now to the choices. Alpha x plus 1 all over 3 plus 2 alpha x squared. Calculate using the same value of x, which is 0.3. Okay, a while ago we used 0.1, but now 0.3. 46 over 75, which is not the correct answer because if we divide this by alpha a, it's not the same. Okay, it's not equal to 1. So how about letter B? So we have 3 quantity x alpha x plus 1 plus 3x squared, alpha x squared. Calculate it using 0.3 as our x. It's not still the same because our answer is 4.8. It's not equal to 1. Okay? How about 3x plus 6? 3 alpha x plus 6. Calculate 0.3. That is still 6.9. That is not equal to 4.8. So this should equal letter D to 4.8. 6x plus 3. Then we have calc. And then we have the answer. Answer divided by the variable a, just to be sure, that's equal to 1. So our answer for this problem equals D. Okay. The correct answer is D. Okay. For this one, find the derivative with respect to u if h equals pi raised to 2u. Okay? So as you can see here, the variable is not x. Okay? It's u. But we will be inputting, since our calculator only have a variable with respect to x, we will transform this variable u into x. Okay? So we input alpha. So we have shift and then just click this. We have the alpha sign here on the scientific notation. Just click shift and this one. And then this is raised to 2. Instead of u, it's x. Okay? So because we will be providing a value of x here. Let's try 0.5. Okay? 0.5. The value is 7.192549999. So shift store with A and then go now to the choices. So we have 2. Okay? And then we have pi raised to 2. Instead of u, we use x. Okay? And then we have ln of pi. Okay? So using a value of x equals 0.5. So this is the answer. So answer divided by the alpha. Okay? The value that we have stored a while ago in a while differentiating this. So equals 1. So definitely the answer for this problem, okay, without trying any other choices, will be equal to letter A, which is, this is the answer. Letter A is the answer. Okay? So how about differentiate? Okay, sine of square root of x minus 1. So the same process. So we have sine, okay? we have the square root of x, okay, alpha x, then minus 1. Close the parenthesis, okay? So because this parenthesis is for the whole derivative, so be careful on the parenthesis. So let's try to use again 0.3. It's up to you if you can use 0.1 consistently, 0.3, 0.5. Okay? So 0.3, shift store to our variable a, then try to calculate the answer. So we have cosine of the square root of alpha x, okay, minus 1 quantity. Then we have 2 square root of x, okay, square root, oops, square root alpha x, okay. Then solve for the value. We have used 0.3, okay. So this is the value. Compare it with variable a. So it's 1. So definitely the answer here is letter A. Okay. So it's very easy. Even if you forgot how to differentiate, okay. Of course, it's better to know, okay, how to differentiate. Okay. But in case you forgot, you know, the calculator technique, then you can answer this if this is a multiple choice question. Since this is board exam, for sure that is a multiple choice. Okay. So number 5, okay? So differentiate x raised to x, okay? So again, same process, alpha x raised to alpha x. Let's use 0.1 as our value. Okay, that's the answer. Shift store to a, okay? And then compare the value or the calculations with the choices. So we have x, alpha x, ln of alpha x. Using 0.1 as our x, compare that answer divided by the alpha a. Okay, that is not equal to 1, so that's not the answer. So next one is we have negative x of ln x. Calculate it using 0.1 and then compare it with the variable a. That is still not equal to 1. So let's move on now to letter C, alpha x raised to alpha x. Okay, and then 1 plus ln of x. And another quantity. Okay? So, calculate it. 0.1. So, we have answer divided by the alpha 1. That is equal to 1. So, definitely, we would that is the answer. And we will not be solving or calculating letter D because it already equals 1. Okay? So, this is the answer. Letter C for this problem number 5. Okay? I hope this is clear to us. So how about problem number 6? So as you can see in our problem here, we'll be using product rule here. Okay? In case you forgot the product rule, okay? So we can use our calculator. So we have alpha x squared. Then we have cosine of 2 alpha x. So don't forget to close the parenthesis of our transcendental function cosine. Okay? And let's now substitute 0.1. Okay? So 0.19, store it to variable a. Okay? And then go now to our choices. Negative 2x alpha x squared. Oops, alpha x squared. Sine of 2 alpha x plus 2 alpha x, then cosine 2 alpha x. Use 0.1 in solving. Then compare it with alpha a. Okay? So, it's 1. So, we're lucky that letter A is the correct answer because that's the first choice that we tried. Okay? So, that's the answer for problem number 6. How about for problem number 7? So, this also works with a inverse transcendental function such as arctan. So, we have arctan. So in order for us to enter arctan, we have to shift, then press the tan here. Then, of course, we have 3 alpha x. Don't forget to enclose it with a parenthesis. Okay? And then, with respect, x equals 0.1. So, store the value, 2.7522 something. Go on with the choices. Okay? So, for letter A, we have 3 all over 1 minus 9x squared. 9x squared here. So, calculate using 0.1. Okay, and compare it with the variable a by dividing it. And it's not equal to 1. So, let's proceed with letter C. Let's try letter C. Because if I know if tangent, that should have a denominator that is a plus. Okay, from what I remember. 3 all over 1 plus 9 alpha x squared. Then calculate using 0.1. So 2.75, compare this to with our answer. Alpha A and Viola, we got 1. So the answer here equals letter C. Okay? Okay, let's go now to problem number 8. Okay, so problem number 8, this is differentiate quantity arc sine of 4x squared. Quantity squared. So the same process, we have to input this in our calculator. So we have quantity, shift, sine. Then we have to enter 4 alpha x and then close the parenthesis for the 4x and another parenthesis for this one, okay? And then squared. So be careful with using the parenthesis. You can type it as it is in the problem, but don't forget that if we are dealing with trigonometric functions, so we have to input or to enclose this 4x with the parenthesis. Okay? Kasi unless otherwise, this would be what do you call this? It would not solve. Okay? It would not continue to solve. Syntax error. Okay, so 0.1 for our x. So 3.59, let's shift store that with letter A. And we will go to the choices for letter A. We have shift arcsine of 4 alpha x all over square root of 1 minus 4 x squared quantity. Solve it, calculate it with 0.1, substituting value of 0.1. So 3.36, compare that with our stored value A. That is 0.9. So still that is not the correct answer. Let's move on now to letter B. Okay, the letter B, the only difference is that letter B is replaced instead of 4x squared with 16x squared. So replace this with 16x squared and then calculate. Okay, so calculate 0.1 still. And then compare this answer. Answer divided by the alpha A. That is equal to 1. So the answer here is letter B. Should be letter B. Let's move on now. How about for problem number 9? For problem number 9, this is inverse hyperbolic. Okay? Inverse hyperbolic of sine x over 2. So, same process. Okay? So, we have hyperbolic here. Okay? Inverse hype here. For sine, we have 4. Okay? So, again, we have x over 2. Alpha x all over 2. Okay? Close this with a parenthesis. Okay? And then calculate with x equals 0.1. So 0.499. Store it with variable a. So we now go to the choices. We have square root 1 all over square root of 4 plus alpha x squared. I think this is not the correct answer. Calculate using the same x. Oh, it's letter A, I think. So let's try to divide it with alpha a. So it's 1. So it's letter A. Okay, since it equals to 1. That is our answer. Okay, so this is for you guys. So use your calculator and your learned calculator technique in this video to solve this problem number 10. Okay? So I'll be commenting down in the comment section what is the answer. Okay? If you have already solved it using your calculator technique. Okay? In order for you to test if you really learned something. Okay? So, again, guys, thank you so much for listening. This is Engineer Abat, and I hope you learned something about the calculator techniques, and I hope this would help you pass the board exam. So, thank you so much again, and God bless.